Hi there. Today, in this logarithm video, we'll be going over some interesting properties about ones and zeros. For it, all you really need to know is what an exponent is. A logarithm, excuse me. Logarithm, not exponent. You should know your exponent rules, though. Those are pretty nice to know for logarithms. Anyway, that is when we're solving for this variable, when a variable is an exponent. So when you have this and you want to solve for this variable here, you would take log base b, the base is what the exponent is acting on, of a, and a is what the original is the answer of, so b to the x equals a, so it's log base b of a equals x. It's not a simple operation like multiplication or addition, so you do need calculator or being able to guess and check to find what exactly makes b, what power of b equals a. But then ones and zeros show up. The only two that are really helpful in that they can be used in algebra or any math really is that if you have the base and what is being acted on the same, it equals 1. To show this, if we turn this back into a exponent form using what we looked at below, that would be b to the 1 equals, without even looking at this, we know b to the 1 is b. And that fits. Similarly here, that's b to the 0, and that equals 1, because anything to the 0 power equals 1. Now you may be wondering, what about 1 to the 1? That would fit here, and that should make it equal 1. Well, that is actually addressed in the second part down here. Anything to the base 0 or 1 is undefined. Now, that might be hard to just take it to face value, so we are going to look at it. So what if we say these actually did equal something, and we say it equaled x? So log base 0 of a is x. So if we turn that into a logarithm form, that would be 0 to the x equals a. Well, a would have to be 0. So in that case, 0 to any power would be 0. So on a graph, that would be a vertical line at 0, at x equals 0, excuse me. And if there's ever a vertical line on a graph, that is undefined, because a vertical line is not a function, because multiple multiple y's equal 1x. And that is a definition of a function. If that is ever violated, it is not a function. Similarly here, this, if we turned it into a exponent form, that would be 1 to the x equals a. Well, firstly, 1 to any power is just 1. So here again it would be a vertical line. This time though, at x equals 1 rather than x equals 0. So same argument, it's a vertical line, so it's not a function. So it's undefined. Now for log, so what if we had, instead of as a base of 0 or 1, we had what is being acted on is 0 or 1. Well, we have 1 up here, so that answers that one at least. But if it is 0, the base can be anything. So again, we turned it into exponential form. It's b to the x equals 0. Well, the only thing that will equal 0 if given to a power is 0 itself. So that's 0 to the x, which is up here. So in the same way, that would be a vertical line at 0. And thus, since it's a vertical line again, it's undefined. So it is interesting to look at cases like this when you see there are special properties with ones and zeros. And ones and zeros are special in a lot of other ways, like with multiplication. A 1 with multiplication, will keep a number the same if you multiply it by 1. And if you multiply it by 0, it turns it to 0. These are aspects looked in more in depth in other higher math, I would say. So Hopefully this was interesting and helped at least by remembering these two up here. Of course, you don't have to memorize, just know how to turn a logarithm into an exponential. So this, if anything, this is something you should memorize because it's not a simple multiplication or addition. Hopefully this helped, and I will see you in the next video.